After decades of international efforts, there is now a realistic prospect that we may leave this episode of human history behind us once and for all. The Comprehensive Nuclear Test Ban Treaty was adopted by the United Nations General Assembly and opened for signature in September 1996. The CTBT bans all nuclear test explosions. It aims at prevention of nuclear proliferation and ultimately at nuclear disarmament. The treaty is backed by a unique verification regime to monitor compliance. The verification regime consists of more than 300 monitoring stations collecting data worldwide, together with consultation and inspection mechanisms. Tibor Tóth is an experienced Hungarian diplomat with a long track record in disarmament matters. He is the Executive Secretary of the CTBTO Preparatory Commission, which was created to prepare for the treaty's entry into force. The Provisional Technical Secretariat of the CTBTO Preparatory Commission is building a verification regime that will let no nuclear explosion go unnoticed by the Commission's member states. In a very remote area, a strong underground explosion is set off using conventional explosives under the auspices of the Commission's Secretariat. The test explosion takes place only seconds after a regular blast in a nearby coal mine. The purpose of this experiment is to test the sensitivity of CTBTO's monitoring system and to calibrate some of its equipment. The next town is more than a 2-hour drive from the site of the explosion. No one here noticed anything about it. The next morning, nearly 7,000 kilometers away from the explosion. When these two technical experts get to their desks at the Commission's Secretariat in Vienna, they will find data about a distant seismic event. The event was recorded by several monitoring stations which transmitted data to Vienna in near real time through CTBTO's global communication infrastructure network. In this case, the analysis indicates a mixture of seismic events. Several monitoring stations recorded a fairly large event, and one station detected also a smaller event which was caused by a mining blast. Seismic waves propagate from the epicenter of a seismic event. When a monitoring station picks up these waves, an ellipse is generated that represents the area of the Earth's surface in which the waves originated. Data from several stations produce intersecting ellipses, and so the location and time of the event become more precisely known. Only later on will the technical experts find out that their analysis matches exactly the pattern of the explosions that had been set up to test the system.
The seismic system plays a fundamental role in the CTBTO technologies. There are 50 primary stations and 120 auxiliary stations. They both are used in a different way, but with these stations we can capture any event. A very low magnitude event can be captured by the system, giving us enough certainty that we will be missing large magnitude or even explosions that take place in the Earth.
The establishment of the CTBTO's unique global system of monitoring stations began in 1997 and is nearing completion. To build the stations, CTBTO specialists had to venture into some of the most remote places in the world. Their job was to set up highly sensitive data collecting instruments and data communication equipment, and to train the local maintenance staff. In 2006, about 2/3 of the monitoring stations were sending data to the International Data Center in Vienna. 3 waveform technologies, seismic, infrasound and hydroacoustic, provide continuous high-quality data streams. The seismic technology measures waves propagating in the Earth. Infrasound detects low-frequency waves in the air that are inaudible to the human ear. And the hydroacoustic technology measures sound waves propagating in the oceans. CTBTO is using standardized equipment throughout the monitoring system. The resulting high quality and homogeneous data produced by the system, which are available to all member states, constitute one of the major assets of the CTBT verification regime. What makes the CTBTO's data bulletin really unique is that waveform data are fused with data from radionuclide detectors. Radionuclide monitoring is the key technology for fulfilling the treaty mandate, the ultimate verification of nuclear explosions. The high-quality monitoring station on the rooftop of the Vienna International Center, itself a training station, is an example of the 80 radionuclide stations being established worldwide to measure radioactive particles in the air. With the radionuclide data, technical experts will be able, upon entry into force of the CTBT, to detect the smoking gun of a nuclear explosion.
The radionuclide technologies at CTBTO can discriminate between nuclear explosion events and any other signal coming from natural background or peaceful nuclear energy applications. Unlike the waveform technology, the radionuclide technology can prove that this event was nuclear. A nuclear explosion, in fact, is injecting into the atmosphere a very unique set of radionuclides that makes our judgment very confident. The transport in the atmosphere afterwards is then delaying the particles produced and released by the explosions so that our station can detect them only a few days afterwards. But fortunately, the information carried by these particles allow us to determine the exact time when they were produced.
The spectral analyses of radionuclide particles will soon be supported by groundbreaking research in noble gases, particularly xenon.
If somebody wants to do a test without that it has been seen, then he will try to do it underground. If it is done underground, then the waveform technology will pick up a signal but cannot distinguish if it is a nuclear explosion or a normal explosion. Neither will there be any radioactive particles in the atmosphere because it's underground. But in the explosion, a lot of radioactive gases are created and they will diffuse through the ground into the atmosphere, and then the wind will blow them over to our stations, and we will have around 40 noble gas stations worldwide, so it will be picked up at least of one station, and so we can identify that the explosion was a nuclear explosion.
But how exactly do the vast amounts of data provided by the four technologies get to Vienna? 6 geostationary satellites transmit the data from the monitoring stations to 5 terrestrial hubs around the globe. From here, the data are piped into the Vienna International Center, where the Commission has its offices.
The Global Communications Infrastructure, or the GCI as we refer to it, is a unique network that covers all 24 time zones and spanning both poles. Central to its design is the use of latest networking technologies in order to fulfill its mission to transport IMS data and IDC products with high reliability and security. And in addition to the technology, we have highly trained and motivated professionals that support the network 24 hours a day, 7 days a week.
The first data processing happens in near real time. Only 2 hours after the data have arrived in Vienna, the first automatic event bulletin is available to member states. The automatic bulletins are then reviewed by analysts. Every analyst needs to be familiar with the characteristics of every monitoring station of the global network. One can say that the analysts are sensing the entire globe from their desks.
The analysis that occurs here is the reduction of this blizzard of gigabytes of information down to a very small amount of information that is useful to state parties. And every one of the events that goes out is basically certified by a human analyst.
The fusion of so much data from the various technologies and stations poses a challenge. At the same time, this makes the CTBTO's data bulletins unique. 30,000 events are recorded every year.
We don't want to miss any event
that occurs either in the atmosphere or in the oceans or underground. Plus we also want to find out whether an event occurred perhaps at the boundaries of these media. And through using the characteristics of each of the waveform technologies, we can improve our understanding of each of those events. So we can perhaps also distinguish a natural event from a man-made explosion or so.
The data fusion is permanently fine-tuned by supporting research. For example, to get a better understanding of how air particles travel from their source to a monitoring station, the CTBTO is developing highly sophisticated models of global atmospheric transport in close cooperation with meteorological organizations.
It is important to understand that the radionuclide released from the nuclear test explosion location towards our radionuclide stations takes place in all three special dimensions. So the radionuclides are transported not only in a horizontal direction, but they can also be lifted upward in low pressure systems, for example, or in thunderstorms, or they can be downmixed in high pressure systems or in the rear of a cold front. So to backtrack our radionuclide measurements to the possible source region, we have to describe the atmospheric transport in the same sophisticated manner on our computing systems.
The fused data make up the data bulletins that go to the national data centers of member states. The member states are getting a special value, not only in terms of the quality of the data, but also as regards the speed of their delivery. It is a unique feature of the CTBTO that the data are made available to the member states in real time. The Japanese Meteorological Association reported that the data which come via satellite from the CTBTO reach it within 30 seconds, which is 1/6 of the time required for data transmitted through the internet.
Tell me, what's happening with H06?
It's been having power problems and we've been opening tickets for it describing
The CTBTO also has a high availability rate of its data. At 98%, it is higher than anyone else's in this field.
Right.
Okay. They might not be here. I'll come.
This operations room in Vienna is the nerve center, controlling remotely all its monitoring stations around the globe.
Okay. We'll have let me ask this to my
Worldwide maintenance logistics are organized from here.
Laptops at least, and they support connections right in the middle of this glass room.
This state-of-the-art computer center began operations in 2005. It houses all central systems and networking devices to support the global monitoring system.
We have mass storage devices up to 180 terabytes, which holds the data forever. Because this is one of our main tasks, to make sure that all the data that we collect from a worldwide network is actually stored forever.
All the data are archived for the national data centers of the member states that signed the Comprehensive Nuclear Test Ban Treaty. The states that host the CTBTO's monitoring stations are getting cutting-edge equipment, software and training. These constitute valuable assets, and training in particular is making a substantial contribution towards capacity building in those developing countries which are hosting these stations.
But these are coming from the same event, but just depending on...
We conduct training to participants from national data centers on how to access, use the data and products and software that is available to the users. The software that we distribute is developed within the Provisional Technical Secretariat of the CTBTO. In order to be able to get the data, users have to be authorized by their member states. This software is available free of charge.
The treaty includes provisions for on-site inspections in case of suspected non-compliance. After the entry into force of the treaty, states may request the Executive Council to approve such an inspection to collect facts on site to determine the true nature of a suspicious event. Such an inspection provides an added measure of confidence for the entire verification regime and can therefore be regarded as the ultimate deterrent. For that purpose, the Commission is drafting inspection procedures, conducting inspection exercises, developing specialized equipment, defining logistical requirements, and developing inspector training programs. Real progress is being made. The potential civil applications of the CTBTO's data products are very promising, in particular in the area of disaster warning and mitigation. Tsunami warning centers have asked the Commission to relay the relevant data, and these are already making a valuable contribution to tsunami disaster mitigation. Leading experts in earthquake and tsunami monitoring agree that the CTBTO provides a speedier, more reliable and more secure route for data communication than any other global data collecting system, an important advantage for tsunami warning systems and disaster mitigation. Data generated in the monitoring of volcanic activity and the data resulting from atmospheric transport modeling could help civilian aviation to stay clear of the dangerous ash plumes. Wind field forecasts could mitigate against hazardous airborne material. The Commission is working in preparation for the treaty's early entry into force, while continuing to develop the quality of its systems.
The global alarm system we are creating is unique. It's unique because of the cutting-edge science. We are relying on advanced technologies for the seismic, hydroacoustic, infrasound and radionuclide facilities. It's unique because of the size. A high number of facilities are put in place in each of the four technologies. It's unique because of the synergy. The four technologies work together in a seamless, integrated way. It's unique because of the partnership. We are building those facilities on the territory of 90 countries. It's unique because of the global nature. The 337 facilities are distributed all around the Earth. And it's unique because of the democratic feature of data distribution. The data and data products are to be shared in real time with all members of our family. And it's unique because of other applications. A vast array of civil and scientific applications exists. Thus, we are creating an unprecedented verification regime, a global alarm system to support the prohibition of nuclear weapon tests.
Any objections?
The work of the CTBTO affects the future security of all mankind. The potential scientific and civil applications of the data it produces could also benefit every inhabitant of this planet.